All right, boys and girls. My entire footage got deleted, and I actually have to start from scratch, and I'm not too happy. It's late at night, but here we go. Um, I'm gonna be showing you amplitude and period of sine and cosine curves. Okay. All right. So here we go. You're either gonna have two types of functions: y equals sine of x, or y equals um, a cosine of x. The amplitude is found by taking the absolute value of A, and you might have one of two scenarios. If the absolute value of A is greater than 1, it's going to be a vertical stretch. If the absolute value of A is less than 1, then it's a vertical shrink. In integrated 3, we called it vertical compression. Okay. Now, greater than 1 or less than 1. What happens if A is equal to 1? Then what that means, it's the original. There's no vertical stretch or vertical shrink. Okay. And then what does the amplitude help you with? The amplitude will help you to find the range. Okay. So remember, it's going to be how high you go up and how low you go. Okay. So awesome. Let's get started. Okay, so I'm going to be doing example 2 checkpoint on page 294. And basically what they want us to do is graph y equals 1/3 of sine of x. I'm sorry, 1/3 sine of x, and b equals y equals, oh, I'm tired. Y equals 3 sine of x. Okay, sorry, there's a glare. And so basically they want us to sketch the graph of each function by hand, and they wanted to do it on the same coordinate. Okay. And this is awesome because our previous example was working with cosine. Okay. So now we're working with sine. And then here's the difference. If you look at these compared to the previous examples, they gave us intervals. They're not giving us intervals now. So they gave us a period, and so now they're not giving us one. So we kind of have to choose our own. So when they don't give us one, we assume that our period is 2 pi. And when we graph from 0 to 2 pi. Okay? Oops. I meant to put brackets. We want to put brackets because that's where it starts, and when it ends, it's finite. And so if you're wondering, how do we get all the points in between? Just take 2 pi and divide by 4. And 2 pi divided by 4 gives you pi over 2. So ready? It's going to be the same coordinates for both, because remember, they don't give us our key points, and they don't give us an interval. So again, it's automatically assumed. And then this is going to help us find our coordinates. So we're going to start with 0. Then we're going to add pi over 2. And then we're going to add pi over 2 to that. So that'll be 2 pi over 2, which is the same as pi. And then we're going to add pi over 2, which is the same as 3 pi over 2. And then we're going to add pi over 2 to that. And if you add pi over 2 to that, it's going to be 4 pi over 2 or 2 pi. And that's it. That's when I know I'm done. Okay. So these are our key points in between. So let me flip it over and let's get started. Okay. I went ahead and plotted these points right here, just our intervals, and 0 pi over 2 pi, 3 pi over 2, and 2 pi. And I distanced them about the same distance in between, so I'm counting every 2. Okay. Now I color coded these so you know which ones we're graphing. So green is going to be y equals 1/3 sine of x. The blue one's going to be y equals 3 sine of x, and the red one I'm not going to plot, but that's just the parent function. And the reason why I wrote it, just to remind you that our first point started at 0, 1. Okay. And one thing I didn't mention earlier, but I'm going to mention it now, is our amplitude here is 1/3. That means as far as our range, it's going to go as high as 1/3 and as low as -1/3. Our amplitude here is 3, so it's going to go as high as 3 and as low as -3. Okay, so to get our coordinates, all we have to do is multiply 1/3 to 0, 1. And if you do that, you end up with, let me use the green. You get the same as 0, 1/3. So it's going to be your first point. And to get our first coordinate for this one, you multiply 0, 1 by 3. So that'll give us 0, 3. Okay. So let's start with the blue one because I think the blue one's the easiest, okay? Um, since I made these every two, like I space them out every two, I'm gonna do like every two is gonna be one. So this is gonna be 1, 2, and 3, okay? So same thing over here, 1, 2, and 3. That way you can really see the curves. Okay, so let me move this up a little bit. Okay. Give me a second. Okay, guys, I apologize if my camera's shaking, but I moved it. Okay, so here we go. The blue one, 3 sine of x. Our first point starts at 0, 3. And then we're going to plot our root. And then we're going to plot our minimum. And it's going to go all the way down here. And then we're going to go up to our root. And then we're going to plot our maximum, which now I'm kind of going into this, which that's okay. I'm going to erase this. And then it's going to be all the way up here. So now we're going to plot our blue line, 3 sine of x. So it's going to go down and then curve and then up and then curve. Now remember, this is just a window, so technically it is infinite. Okay, so this is what it should look like, but it's just a little window that we chose. Okay, so now we're going to do the green one. The green one is 1/3 sine of x. I wish maybe I would have done them by threes, because that way I would have picked one of these, but that's okay. So a third, we're going to start at 0, 1, 3. So again, it's just an estimate. I'm just going to say a third is about here. Okay, so it's going to go as high as 1/3. Then it's going to go root. It's going to cross in the same x-intercept, but then it's going to go down below to, let's just say here. And then it's going to go as high as here. So it's going to go curve, curve, curve. Obviously, the one with the amplitude that was bigger was stretched. The green one with the amplitude of 1/3 was shrunken. Okay, so it looks something like this. Okay, again, you can always check your answers using a calculator. All right, awesome. Since this is similar to example 1, I'm gonna give you an example to try on your own. Okay. So now I'm going to move on to example 3. Okay, here we go. Now we're going to talk about periods. So you're going to have one of two functions, either y equals a sine of b of x, or b times x, and y equals a times cosine of b times x. Okay. And your b is now going to help you find your period, because the way you find your period is you take 2 pi divided by b. Okay, if your b happens to be anywhere between 0 and 1, that means you're going to have a horizontal stretching, and what that means is your period's going to be greater than 2 pi. Okay, so it'll extend. And if b is greater than 1, you're going to have a horizontal shrinking, and your period is going to be less than 2 pi. Okay, and then a couple other things I want to note. Okay. The other thing I wanted to note is when b is negative, you're going to use some of your trig identities. Okay. So sine of negative x, again, when b is negative, is the same as negative sine of x. And what that means is when the negative is in the front, is the same as a reflection in the x-axis. Okay. So if the negative is in front of your function, it'll be a reflection in the x-axis. But what happens when your b is negative with cosine? It doesn't make any difference. It's the same as writing it as cosine of x. So it still remains positive. Okay, so just remember that. So you're going to have two different scenarios. And the only one that it really affects is the sign. Okay? All right, you guys, let's get started with our first example. I'm going to do the extra example 3 because I think I'm going to give you guys the checkpoint on page 295. Okay? So here we go. Y equals cosine of x over 4. So let me give you this equation. A cosine of b of x. So just from here, you should know a couple things. Your amplitude is 1. Okay. Remember, if you don't see an A there, it's automatically 1. So what that means is your range is going to be greater than or equal to -1 and less than or equal to 1. So it'll go as high as 1 and as low as -1. And then your B, let me use a different marker. Your B is actually 1/4. And remember, your B is going to help you find your period. So it's 2 pi over 1/4. Okay. And then let's simplify that. So 2 pi over 1/4 is the same as 2 pi times 4, which is 8 pi. So what your period helps you with is to find your interval. So your interval is going to be 8 pi. Okay. Now remember, this is going to help us to find our key point. So we're going to start at 0 and we're going to end at 8 pi. But how do we find our points in between? Well, take 8 pi and divide it by 4, and that gives you 2 pi. So we're going to add 2 pi and we'll stop at 8 pi. So 0 plus 2 pi will give us 2 pi. 2 pi plus 2 pi will give us 4 pi. 4 pi plus 2 pi is 6 pi. And 6 pi plus 2 pi, 8 pi. So these are the points we're going to put on our coordinate. All right, awesome. Let's get started. Okay, so I plotted my points. So this is like my window. And remember that the parent function starts at 0, 1, and this has an amplitude of 1. So guess what? We're also starting at 0, 1. So I'm going to make every 2 increments 1, okay? So 0, 1 would be here. So you start there. Then it's maximum, root, minimum, root, maximum, okay? So it'll look like that. I always like to start over here just so I could start curving it. Okay. And this is it, guys. That's it. There's not much to it. Okay. All right. Awesome. So I think now you have enough to get started, and then I'll give you some examples, and then we'll move on.